Welcome at PCIM Europe 2023. We are at the Futurre Electronics stand. I'm Riccardo Collura, Vertical Segment Manager for Analog and Power Solution at Futurre Electronics. And today I'm with Akif Polat, one of our power specialists based in Istanbul. Akif, wide bandgap is very important, but it's a bit different to drive silicon carbide or GaN compared with superjunction. And I can see here we have a lot of demo board. Can you tell us a bit more about what we have here today?
Sure. We have several evaluation boards for driving silicon carbide and GaN MOSFETs here. For sure, it is different to drive GaN MOSFETs and silicon carbide MOSFET when compared with the silicon standard conventional silicon IGBTs and MOSFETs. Because of the high dV over dt and high switching performance, you need to take special measures on the driver side and also in the layout. First, we can start with on-semi isolated dual channel gate driver evaluation board. Here, a dual output gate driver for silicon carbide MOSFETs is showcased. It can drive up to 1200 volt silicon carbide MOSFETs in dual configuration, so it can be used in half bridge or dual low side applications. It's an isolated gate driver, and common mode transient injection values are above 200 volt per nanosecond.
So this is very important because basically our customer can look at the waveforms and can make sure that this is the right driver, the right device. Because I think even with silicon carbide, different vendors, they've got different voltage level to drive. So it's important to choose the right gate drivers. Is that correct?
Yes. Especially gate drive voltages. Selecting a right gate driver voltage is important. So in standard MOSFETs or IGBTs, gate drive voltage can be like 15 volt to minus 5 volt, but in silicon carbide MOSFETs it can be 15 to 18 volts, and in minus gate voltage could be down to minus 3 or minus 4 volts. So right gate drive voltage must be selected in order to drive the silicon carbide MOSFETs.
Otherwise, you don't get the benefit from the wide bandgap device.
Yes.
Okay. And I can see here also module, because this is discrete, but it's important also with the silicon carbide module to have the proper drive. So I can see different solutions here from Infineon, from Microchip.
Yeah. From Infineon, there is a unique solution. It's a silicon carbide IPM with 3 half bridge states integrated. But the gate driver is also integrated in the bootstrap configuration. It can be used in motor drive applications. In this case, it can drive up to 8 kilowatt out motor. Inside this IPM, there are 1200 volt silicon carbide MOSFETs and 55 milliohm RDS(on) resistance value, and the efficiency for the inverter stage can go up to 99%. So in this kind of application with the integrated gate driver, you can use direct PWM. You can apply the direct PWM signal to the input of this IPM. But if in modules, approach is a bit different. You need to use separate gate drivers. So it is a good fit for a motor drive application.
And what about this one?
This one is an integrated gate driver on top of a silicon carbide MOSFET module. This module is a high current module from Microchip, 1200 volts voltage withstand value, and the current values higher than 500 amps with a very low inductance value. For driving this module, Microchip is providing an agile switch board, which can be mounted on top of the silicon carbide module. And this gate drive voltage can be configurable, digitally configurable, and you can apply several gate voltage steps to control the dV over dt during the switching by using agile gate drivers.
So all these evaluation boards are available for our customer at Futurre Electronics. Just come to us and we'll help you in your design and speed up your design and understanding better how to drive silicon carbide or GaN. Thank you very much, Akif.
Thank you.